Hey, math magicians. We are going to walk through discovering the magic of number theory. And oftentimes we overlook number theory because we think, oh, we learned our numbers when we were um, little, when we were counting. And then we get to questions on academic team, questions they'll ask about, like, what are natural numbers or what's the prime factorization of something? And then we are like, wait, what? And so we're going to spend a few videos going over different types of numbers. So the next few videos, we're going to have prime factorization, relatively prime numbers. We'll have another video on greatest common factor, least common multiple, another one on perfect squares, and another one on rational and irrational numbers. And the way we're going to do this is I'm going to do a little bit of a review, and then we're going to jump into some practice problems. My plan is to use IXL or Bookit or quizzes to kind of um, get those practice problems in. So let's start with the prime factorization, and relatively prime numbers. So prime numbers only have two factors, one in itself. If it has more than two factors, it's called composite. There are only two numbers that fall into neither category, and those numbers are 0 and 1. And the reason why 0 and 1 are not prime nor composite is because 0 and 1 don't have two factors, and they don't have more than two factors. So 0 doesn't have any factors, and 1 only has one factor itself. However, the number 2, the next number that comes up, that is a prime number. And the reason why 2 is a prime number, because it has exactly two factors. 2 times 1 is 2. 3 is a prime number. 3 times 1 is 3. But then when we get to 4, 4 is a composite number because it's 1 times 4 and 2 times 2. So it has three factors, 1, 2, and 4. So then you can move yourself up. There's only one even number that's prime, and that's 2. All other numbers, all other even numbers, rather, are considered composite because 2 is a factor of all the other numbers. So it'd be 1 itself and 2, and then some other numbers as well as you move up. So hopefully that helps with prime numbers. It's just a quick review. I know you've learned it already, but it's always good to review that. Now, prime factorization, this is what we're going to focus our IXL on today. That is breaking a number down until all the factors are prime numbers. Okay, so we're taking any number, a bigger number, and we're breaking it down. And on IXL, you're going to see some exponents here, so we'll get some extra practice there. And then the next one, this one right here, is something that might be new for you. It's called relative prime numbers or relatively prime numbers. Oftentimes on academic team questions, like on Governor's Cup, they're going to ask you what would be a relatively prime number. And sometimes we're like, wait, I know what prime is, but I don't know what relatively prime is. Relatively is how it relates to each other. So if it's relatively prime, the only factors that it has in common is just one. Okay, so they don't have any other factors in common other than one. So that's what a relatively prime number is, in case you're ever asked that. All right, well, let's do some quick practice on prime factorization. So here is our first one. Write the prime factorization of 12. Use exponents when appropriate and order the factors from least to greatest. Okay, so we're gonna do 12. I'm gonna move this over here real quick. And so we're going to break 12 down into, I'm going to make it a different color. So we're going to break 12 down into its prime numbers. So all I'm going to start with is I'm going to make a little factor tree. This is kind of how I do it. There's other ways to do it. I do factor tree because it's easiest for me. So we could say 2 times 6, which would work. We could also say 3 times 4. I think I'm going to do 3 times 4. 2 times 6 is perfectly fine, but I'm going to do 3 times 4. Now, look at 3 and 4. Are either of those numbers prime? So the 3 is prime. So what I do is I circle it, and then I move over to 4. Is 4 prime? No, 4 is composite because you can break it down into 2 times 2. So we're going to break this down to times 2. And we know that 2's are prime, because remember, 2 is the only even number that's prime. And so now all of our numbers are prime. So we have 3 times 2 times 2. And when we wrote it, it said order them from least to greatest. So I'm going to order my 2, and it's 2 squared. So you're going to be a little exponent there, 2 squared, and then it's going to be times 3. So 2, whoopsie, we're going to, nope, sorry, 2. Do it correctly. I messed up there when I hit my enter button, sorry, but it would be 2 squared times 3. So we knew it, that, but you run into maybe writing it in incorrectly. So I'm going to get the next one right. All right, so now we're going to do prime factorization of 8. That's an easy one. We know 8 is 4 times 2, and then 4 is 2 times 2. So you're going to get 2 times 2 times 2, or 2 to the third power. Okay, and I guess, oh, that's how you do it. Okay, so that's the part. It's going to make sure we know what we're doing here. All right, now prime factorization of 15. 15 is 5 times 3. Well, 5 and 3 are both prime, so I'm going to do 3 times 5. I want some harder ones. I'm going to go ahead and move up to a harder level. Why are we doing all the easy ones? What in the world? 19. Well, 19 is prime factorization of 19. 19 is prime, so we're just going to put 19 in there. Prime factorization of 2, that's 2. Why are they not giving us hard? There we go. Now we're going to get a hard one. Why are we waiting until 95 to get a harder one? Okay, 174. I love this one. Okay, so let's go ahead and do 174. Okay, so we know that. So when you're given a number that's a little bit bigger like this, the immediate thing that I do is I go to the last number. Is it odd or is it even? If it's even, then I know that I can do 2 times something. So whatever 2 times. So we know that this would be what, 87, right? Because 2 times 80 is 160. 2 times 7 is 14. So 80, 2 times 87. Well, I know this is prime, but then I get to 87 and I'm like, okay, this is an odd number. It's not, so it's not divisible by 2, but is it divisible by 3? And so how do I know if it's divisible by 3? Well, the easiest way to know if it's divisible by 3 is the sum of the digits. So I would do 8 plus 7. So 8 plus 7 is 15, right? Well, if 8 plus 7 is 15 divisible by 3? And if the answer is yes, in this case it is, then the whole thing is divisible by 3. So we know that 87 can be broken down. So 3 goes into 8 2 times with 2 remainders. So that'd be 27. And then 3 times 9 is 27. So 3 times 29 is 87. So 3 is prime. And so now we got to figure out, okay, it's 29 prime. So let's do the same thing. 9 plus 2 is 11, and 3 won't go into 11. So it's not that one. 4 is not going to go into it because it's not even. 5 is not going to go into it because the rules for 5s. 7 times 4 is 28. So 7 is not going to go into it. 8's not, 9's not, because 9 times 3 is 27, and 9 times 4 is 36. 11 won't, because 11, 22, 33. So 13's the other one, and 13 times 2 is 26. So we could pretty much guess that 29 is going to be prime. So we've got 2 times 3 times, I'm going to circle this because it's prime, 2 times 3 times 29. So 2 times 3 times 29. And we got it. All right, so now let's do 54. And this will be our last one. 54. We're going to break 54 down. We know it's even. I automatically go ahead and do the 2. Okay? It just makes it easier. 2 times 25 is 50. So this would be 2 times 27, because 2 times 2 is 4. So 2 times 27 is 54. We know that the 2 is prime. Now 27. So again, if you weren't 100% sure what goes into that, go ahead and immediately go to 3. 2 plus 7. 2 plus 7 is 9. 9 is divisible by 3, so the whole thing's divisible by 3. So then it would be 3 times 9 is 27. So we know 3 times 9 is 27, and we know 3 is prime, but then 9, we know 9 is 3 times 3. So we're going to do 3 times 3. So now we got a bunch of 3's here. 2 times 3 times 3 times 3. So when we write our prime factorization, 2 is the least, times 3, and we have 3 3's, so it'd be 3 to the third power. Let me put all 3 in there. There we go. Yay! Oh, it got to be 99. We have to do it. We have to do the next one. Sorry. All right. I can't leave it on 99. I gotta get my star. 241. Okay, so we got our 241. Okay, so this is a good rule for looking at the 3, because it's like, okay, what's it divisible by? So 2 plus 4 is 6, plus 1 is 7, and 7 is not divisible by 3, so the whole thing is not divisible by 3. It's not divisible by 2 because it's not even. So then we got to look. It's not divisible by 5 because it doesn't end in a 5 or a 0. It won't be divisible by 6 because the rule for 6 is it has to be divisible by both 2 and 3. So 7. So we could see if it's divisible by 7. So we've got 241, and if we divide that by 7, we get like a decimal because it's not going in there. It's like 34.4. So that's not working. Not 8. Not 9 because it's not divisible by 3. Let's look at 11 because 11 is our next prime number. So 241 divided by 11, it's not going to go in there either. It's like 21.9 something. So on this particular one, I don't know. I'm maybe 13. I'll look at 241 divided by 13 and we'll see that. Nope, that's not working either. Now, before I hit enter and be wrong, I am going to check. I'm going to see, is 241 prime? Yes, it is. 241 is a prime number. So we got it right. So we're just going to put 241 in there. It kind of left us hanging on that last one. And we got our gold medal. So hopefully this helped you. We've got, like I said, we're looking at prime factorization and relatively prime numbers. Remember, prime numbers only have 2 factors, one in itself, and relatively prime numbers are 2 or more numbers that their only common factor is 1. Okay, hopefully this video helps. Have a great day.